So hey guys, so in this video we are going to solve problems involving the limits and continuity of a function. So let's get started with the first problem. Evaluate the limit of x squared minus 3x plus 2 all over x squared minus 4 as x approaches 2. Okay, when we do direct substitution, the result will be indeterminate. So let's show. That will be 2, okay. That will be 2 squared minus 3 times 2 plus 2 all over 2 squared minus 4. And 2 squared is 4 minus 6 minus 2 all over 4 minus 4, which is 4 minus 6, negative 2 minus 2, 0. And 4 minus 4 is 0. So indeterminate, this means that the limit exists. And so we have to do manipulation in the given function. We'll do factoring. Okay, we have the limit. So as x approaches 2, we know that automatically the numerator has a factor of x minus 2. Same with the denominator because it approaches to 2. So we have x minus 2. Then what will be multiplied to x minus 2 to come up with x squared minus 3x plus 2? That is x minus 1. Okay, because x times x squared, negative 2x plus negative x, negative 3x, and negative 2 times negative 1 is positive 2. All over, that will be x plus 2 times x minus 2. So we can cancel x minus 2. Then we can evaluate the limit as x approaches 2 of the function x minus 1 over x plus 2. So in here, we can do substitution. That is 2 minus 1 all over 2 plus 2. And so we have 1/4. So the answer to this problem is 1/4. Okay? Next problem. How about the limit of the square root of x squared plus 4 minus 2 all over x squared as x approaches 0? So in here, if you do substitution, the result will be 0 over 0. So we have to do some manipulation. And we are going to use the concept of conjugate. And we know that if we have a function a plus square root of b, the conjugate will be a minus square root of b. Alright, so let's solve. So we have the limit of the square root of x squared plus 4 minus 2 all over x squared as x approaches 0. So you multiply the numerator and the denominator by the conjugate. That will be x squared plus 4 minus 2, that's plus 2 over x squared plus 4 plus 2. Okay, that will be equal to x squared plus 4 times the square root of x squared plus 4. Just cancel square root. That will be x squared plus 4. Then negative 2 times negative 2, that will be negative 4 all over x squared times square root of x squared plus 4 plus 2. Then simplifying further, we have 4 minus 4 is 0. So that will be x squared all over x squared times the square root of x squared plus 4 plus 2. And this will be cancelled. So we have the limit as x approaches 0 of 1 all over square root of x squared plus 4 plus 2. And by substitution, we have 1 all over square root of 0 squared plus 4 plus 2. And that is equal to 1 over square root of 4 plus 2. So we have 1 over 2 plus 2 equals 1/4. So the answer is 1 over 4. Okay, next problem. Compute the limit of the quantity 2x squared minus 3x plus 4 over x plus 5x minus 4 over x. Okay, as you can see, if you do substitution, the result is undefined. Meaning we have a non-zero real number in the numerator and a 0 in the denominator. But if you observe the given function, we can combine them because they have the same denominator. So we can just first add the given function. So we have 2x squared minus 3x plus 4 plus 5x minus 4, common denominator of x, and we have 2x squared negative 3x plus 5x, that is what? 2x. Okay, 4 minus 4, 0, all over x. Okay, and then that will be the limit of 2x squared plus 2x all over x as x approaches 0. So as you can see, if we do substitution here, the result will be indeterminate. Okay, and then we can factor out the numerator, and that will be equal to x times 2x plus 2 all over x as x approaches 0, because x times 2x is 2x squared, x times 2 is 2x. So we can cancel x, and we can now do substitution. So the limit of 2x plus 2 as x approaches 0, and that is equal to 2 times 0 plus 2, which is equal to 2. So the answer is equal to 2. Okay, next one. Excuse me. How about the limit of sine x squared over 5x squared as x approaches 0? So we know that we have a special limit, that the limit of sine x over x as x approaches 0 is 1. We can use this. As you can see, if the given angle is x, the denominator should be also x. And as you can see in the numerator, we have x squared, and we have also x squared in the denominator. And so we can write this as the limit, so as x approaches 0, of 1/5 times sine x squared over x squared. And we know that the limit of 1/5 as a constant is 1/5. Then the limit of sine x squared over x squared, so we can use this, which is 1. 1/5 times 1 is 1/5. So the answer is 1 over 5. Next. And we have tangent here. We know that based on our previous solution, that the limit of tangent x over x as x approaches 0 is equal to 1. We can use this. So we have the limit, so as x approaches 0, of sine 5x over tangent 3x. We can divide this by x, also this by x, and then we have to multiply it by 5, multiply by 5, multiply by 3, then multiply it by 3. And so we can now have the limit of sine 5x over 5x is equal to 1. Then the limit of constant 5 is 5. The limit of tangent 3x over 3x is also 1. The limit of constant 3 is 3. So 1 times 5 is 5. 1 times 3 is 3. So the answer is 5 over 3. Okay. So use the limit laws and graphs of f and g in figure 1 to evaluate the following limits. Okay. Take a look. We have letter A. Here, the limit of the function f of x plus 5 times g of x as x approaches negative 2. So limit laws. What will be the limit of f of x? F of x here is the pink graph, and g of x is the blue. So what's the limit of f of x as x approaches negative 2? Negative 2. Okay. This is our negative 2. Okay. Up from the left. So negative 2 from the left, the limit is ganon, is 1. Then from the right, that is also 1. Therefore, the limit of f of x as x approaches negative 2 is 1. So we have 1 plus the limit of g of x as x approaches negative 2. So g of x here, negative 2. So from the left, that is negative 1, right? This is negative 1. Then from the right, also negative 1. So we have 5 times negative 1. And that is 1 minus 5, negative 4. So the answer is negative 4. How about letter B? The limit of the product of f of x and g of x as x approaches 1. So what is the limit of f of x as x approaches 1? So this is our 1 here. 1, 2. So from the right, the limit is 2. And from the left, the limit is also 2. That is 2. Then g of x, from the x approaches 1, okay? From the left, here, what's the value? Ito, negative 2. Galing sa left, papunta kay 1, negative 2. And galing sa right, papunta kay 1, negative 1. So the left and right hand sides are not equal. So we can say that the limit of g of x is does not exist. So we cannot multiply 2 to does not exist. Therefore, the answer here is what? Does not exist. So the limit of the given product does not exist. Okay, next. Last, we have the limit of f of x over g of x as x approaches 2. Limit of f of x as x approaches 2. So this is 2. So all right. So f of x here, we can assume that this is 1.5. Okay, or 3 over 2. So the limit of f of x as x approaches 2 from the left, that will be 1.5 here. Then from the right, the same, also 1.5. Sabihin natin in fraction, 3 over 2. Then, ano next? We have the limit of g of x as x approaches 2. Here, 0. So you can see 0. From the left, that is 0. And then from the right, also 0. So 3 over 2 divided by 0, that will be undefined. Okay? So that's how to evaluate limits applying the limit laws based on the given graph. Okay, proceed to the next. Where is the function f of x equals 1 over x squared minus 6 continuous? Okay, so as you can see, this is a rational function. So to determine the numbers in which the function this function is continuous is to identify first the domain of the function. So as you can see, the denominator x squared minus 16. So if we factor this, that will be x plus 4 times x minus 4 equals 0. So we have two values of x, negative 4, positive 4. Meaning, the function is continuous at any numbers except negative 4 and 4. Okay? All numbers except negative 4 and 4. Because when x is negative 4 or 4, the denominator becomes 0. And that makes it discontinuous. Okay? So the function is asking for the continuous function, meaning all numbers except negative 4 and 4. But if the question is, where is the function discontinuous? So the answer is negative 4 and 4. But the question here is, where is the function f of x continuous? So all numbers except negative 4, 4. Okay? So next one. Examine whether or not the function f of x equals x cubed minus 2x plus 1 if x is less than or equal to 2, and 3x minus 2 if x greater than 2 is continuous at x equals 2. So we are going to use the three condition at x equals 2. So we have condition 1, we have to find f of 2. So f of 2, x equals 2 belongs to the first subfunction because we have x less than or equal to 2. So we substitute 2 cubed minus 2 times 2 plus 1. 2 cubed is 8, minus 2 times 2 is 4 plus 1. 8 minus 4 is 4 plus 1, 5. Okay? So 2 cubed, 8 minus 2 times 2, 4 plus 1. So 8 minus 4 is 4 plus 1, 5. Okay. So the first condition is satisfied because we have a value of f of 2. We have the second condition, the limit of f of x as x approaches 2. And so we have to consider first the left and the right. As x approaches 2 from the left, so less than 2, that will be the first subfunction, whose value is also 5. Then the limit of f of x as x approaches 2 from the right. So that will be the greater than 2, which is the second subfunction. So we have to substitute 3 times 2 minus 2. So 3 times 2 is 6 minus 2, that is equal to 4. So what is the limit of f of x as x approaches 2? The answer is does not exist. Why? Because the left and right hand sides are not equal. Okay? This means that the given function is discontinuous at x equals 2 because the second condition is not or does not satisfied or did not satisfy. Okay. Gets? So proceed with the next one. So suppose that f of x equals a plus x if x is less than 2, 1 plus x squared if x is greater than or equal to 2. Find a value of a such that the function f of x is continuous at the point x equals 2. Also, we are going to use the three condition of continuity. So we have condition 1. Oh, sorry. We have condition 1. We have f of 2. So what is f of 2? We are going to use the second subfunction because x is greater than or equal to 2. So that is 1 plus 2 squared. And that is equal to 5. Okay? And then condition number 2. So we have the limit of f of x as x approaches 2. So we check first the left. So f of x as x approaches 2 from the left, and that will be the first one. So we have a plus x, so a plus 2. Okay, then the right, so we have x approaches 2 from the right, and that is 1 plus 2 squared, which is 5. So the left and right should be equal to make it continuous. Okay, so that will be a plus 2 is equal to 5. Then solving the equation, we have a equals 5 transpose 2, so minus 2. 5 minus 2 is 3. So the value of a is equal to 3. That makes the function continuous at the value of x is equal to 2. Okay, next one. So which of the following is true for the function f of x given by f of x equals to x minus 1 if x is less than negative 1, x squared plus 1 if x is negative 1, x is greater than or equal to negative 1 but less than or equal to 1, and x plus 1 if x is greater than 1. A, f is continuous everywhere. B, f is continuous everywhere except negative 1 and 1. C, f is continuous everywhere except negative 1. And D, f is continuous everywhere except x equals 1, and none of the above. So the answer here is C. So I am going to show to you why is it C. So check natin at x equals negative 1 first. So we have condition 1, f of negative 1, that will be the second subfunction because x is greater than or equal to negative 1. So that will be negative 1 squared plus 1. Negative 1 squared is 1 plus 1, so 2. Then we have the condition 2, the limit of f of x as x approaches negative 1. Negative 1 from the left, that will be the first. Okay, so we have the limit of f of x as x approaches negative 1 from the left. The first one, less than negative 1. So we have 2 times negative 1 minus 1. That will be negative 3. 2 times negative 1 is negative 2 minus 1, negative 3. Then the limit of f of x as x approaches negative 1 from the right. That will be greater than negative 1. So the second subfunction, x squared plus 1, whose value is 2, right? As you can see, the left and right are not equal. So therefore, we can say that the function the limit of the function does not exist at x equals -1. So we can say that the given function is discontinuous at x equals -1. Next one. How about at x equals 1? So we have first condition, we have f of 1, that will be the second subfunction, x less than or equal to 1. So we have 1 squared plus 1, that is 2. Second condition, we have the limit of f of x as x approaches 1. So from the left, okay, so we have the second, x is less than or equal to 1 here. So second, 1 squared plus 1, so 2. Then from the right, that will be greater than 1, which is the third one, x plus 1. So 1 plus 1, that is equal to 2. So the limit is equal to 2 because the left and right are equal. So the value of first and second conditions are equal. So we can say that the function is continuous at x equals to 1. So as you can see, we cannot accept this answer because f is not continuous everywhere, because we can see that the function is discontinuous at x equals -1. Discontinuous siya dito at x equals 1 ay continuous. Okay? So f is continuous everywhere except -1 and 1. That is incorrect because the function is continuous at x equals 1. So D, f is continuous everywhere except x equals 1, but this is continuous at x equals 1. So this is the answer. The f is continuous everywhere except -1 based on our solution. Next. So find the intervals on which each function is continuous. Okay, the function is the piecewise function, x squared plus 2x plus 1, x less than 1, and negative x over 2x greater than or equal to 1. So if you graph the function, since the graph is already given, we can easily identify the interval. So the function is continuous on the interval except this portion right here, because we have a hole and a jump between the two portions of graph. Okay, so therefore the function is continuous here and in here. So we have to use the notation of interval for the answer. So f of x is continuous on the intervals here, infinite. So sa left, so that will be -infinity to 1. But as you can see, we have a hole in the x equals 1. So disregard natin, we use parenthesis, meaning open interval, 1 is not included. Okay, so the function is continuous on this interval, -infinity to 1. Is there any other interval for which the function is continuous? Yes, we have here. And that will be close interval, left close interval, because we have a shaded portion to positive infinity. Okay, so yan, the function is continuous on that intervals. If the given number or interval is not on that two intervals, we can say that they are the function is discontinuous. Next. Determine the interval for which the function is discontinuous. So we have the function f of x equals x plus 5 over x squared minus 3x plus 2. And here are the choices. As you can see, this is a rational function. Let us consider the domain. So we have x squared minus 3x plus 2 equals 0. Then by factoring, that will be x minus 2 and x minus 1. Okay, so we have x equals 2 and x equals 1. This means that the function is continuous at any number or interval that does not include 2 or 1. 2 and 1. So, and therefore, since the question is asking for the discontinuity, all interval that includes 2 or 1 or 2 and 1 are the answers. So 0, 3, the closed interval 0, 3, it includes 2 and 1. Therefore, this is discontinuous. Okay, discontinuous siya at 0, 3. Negative 3 and negative 1. So, all numbers between negative 3 and negative 1 inclusive. So, meaning, as you can see, 2 and 1 are not here. Therefore, this is continuous. 2 to 6. So, 2 is here but it is a open interval. An open interval meaning excluded. Hindi kasali si 2. So, numbers from 2.001 and up to 6 which is excluded pa rin si 6. So, continuous din siya. Okay? How about the open interval 1, 2? This is also continuous because this means that the elements of this interval will be all the numbers between 1 and 2 excluding 1 and 2. So meaning hindi kasali yung 1 and 2, lahat ng numbers between them. Okay? That's why this is continuous because hindi naman included si 2 and 1. So ganyan lang. Okay, last one. The given function is continuous at any number. Find m plus k. So the function is x cubed minus 1 if x is less than or equal to negative 1, 2mx squared minus 5k, x plus 1 if x is greater than negative 1 or less than or equal to 2, and 1 minus 4x over x plus 5 if x is greater than 2. Let us check the continuity at negative 1 and 2. Okay, so let us have first at x equals negative 1. Okay, we have the first condition. So we have f of negative 1. That will be the first subfunction. X is less than or equal to negative 1. So we have negative 1 cube minus 1. And that will be negative 1 minus 1. Negative 1 minus 1, negative 2. Condition number 2. We have the limit of f of x at x approaches negative 1. So we have left side muna, negative 1 from the left. Same with the f of negative 1. So that will be negative 2. Then the limit as x approaches negative 1 from the right. So f of x. That will be the second subfunction because x is greater than negative 1. So substitute negative 1 for x. So that will be 2m times negative 1 squared minus 5k times negative 1 plus 1. And that will be negative 1 squared is 1 times 2m, 2m. Negative 5k times negative 1 is 5k plus 1. The left and right should be equal. This means that we have an equation 2m plus 5k plus 1 equals negative 2. Or, or 2m plus 5k equals negative 2 transpose 1 to the right, negative 2 minus 1, negative 3. So this is our first equation that we are going to use to find the value of m and k first. Next, let's go to positive 2. So at x equals 2, so we have the first condition, f of 2. That will be the second, x is less than or equal to 2. So we have 2m times 2 squared minus 5k times 2 plus 1. That is 2 times 2, 4 times 2, 8m minus 10k, 5 times 2 plus 1. Then, that will be the answer for f of 2. So we have the limit of f of x as x approaches 2 from the, approaches 2. Okay, left muna. So limit of f of x as x approaches 2 from the left. That will be the second subfunction again because x is less than or equal to 2. So the value is also this. So that will be 8m minus 10k plus 1. Okay. Then from the right, the limit of f of x as x approaches 2 from the right. So that will be the last. So x greater than 2. So 1 minus 4 times 2 all over 2 plus 5. That is 1 minus 8 over 7. So negative 7. Divide 7 equals negative 1. And so, the left and right should be equal also. We have equation 8m minus 10k plus 1 is negative 1. Or we have 8m minus 10k is negative 1 minus 1, or 8m minus 10k is equal to negative 2. Okay, to simplify this, we can divide all the terms by 2 because divisible naman. 8 divide 2, 4m. 10 divide 2, 5k. Negative 2 divide 2, negative 1. Okay, we have equations 2m plus 5k equals negative 3 and 4m minus 5k is negative 1. We will solve this simultaneously to come up with the values of m and k. So we have 2m plus 5k equals negative 3, then 4m minus 5k equals negative 1. By elimination method, we can eliminate k because we have the same coefficient and opposite sign. So addition, 5k plus negative 5k, 0. 2m plus 4m, 6m. Okay? Negative 3 plus negative 1, negative 4. Divide by 6. So therefore, cancel. M equals negative 2/3. So we have a value of m now, negative 2/3. Then to solve for k, so we can use equation 1. So 2m plus 5k negative 3 by substitution. 2 times value of m is negative 2/3 plus 5k equals negative 3. 2 times negative 2/3, so negative 4/3 plus 5k equals negative 3. Negative 4 over 3 plus 5k equals negative 3. To remove the denominator, multiply all the terms or both sides by 3. So we have cancel 3, negative 4. That will be negative 4 plus 3 times 5k, 15k. 3 times negative 3, negative 9. So 15k is equal to negative 9 plus 4. Transpose negative 4 to the right, becoming positive 4. So 15k equals to negative 5. Dividing both sides by 15, k is equal to negative 5 over 15 or negative 1/3. So we have a value of m and k, but we are going to find m plus k. Here na lang. Okay. Therefore, m plus k will be the value of m, negative 2/3, plus the value of k, negative 1/3. Okay, so negative 2 plus negative 1, negative 3 over 3. So negative 3 by 3, negative 1. So the answer is negative 1. Okay, so that's all for the different problems involving limits and continuity of a function.